गुड इवनिंग सर।
गुड इवनिंग। आज कौन सा टॉपिक करके आए हैं?
सर आपने रिएक्शन मैकेनिज्म बोला था। बेसिक्स बेसिक तो कल हो गया था। मैंने सर पेरिसाइक्लिक भी देख लिया ऑलमोस्ट। पेरिसाइक्लिक भी हो गया मेरा। हाँ
कोई
सर।
नहीं, डिस्कस कर लेंगे हम।
हाँ सर।
अभी हम रिएक्शन मैकेनिज्म करेंगे ना,
हाँ सर। यस।
डिटेल में। डिटेल में
हाँ
एनालिसिस।
सर। यस सर।
यस, स्टार्ट कीजिए। रिएक्शन मैकेनिज्म, व्हाट इज रिएक्शन मैकेनिज्म, व्हाट द मेन पर्पज ऑफ रिएक्शन मैकेनिज्म इन ऑर्गेनिक केमिस्ट्री, व्हाट द मेन पर्पज ऑफ रिएक्शन मैकेनिज्म इन ऑर्गेनिक केमिस्ट्री, what the application of reaction
यस।
mechanism and how many types of reaction mechanism, explain one by one.
यस सर। सर reaction mechanism is basically the reaction from reaction mechanism we can get the exact pathway through which the product is formed basically. Okay. So and from reaction mechanism we came to know about the which product is thermodynamically, that means which product is more stable. Okay. If the product is formed fast, then it is called kinetically controlled product, and if the product is from that means from at high temperature, then it is called that means from reaction mechanism we can come to know about the more stable, that means the which product will be the major product, which product will be the minor product, all thing we came to know from reaction mechanism. And from reaction mechanism we can synthesize, with the help of reaction mechanism we can synthesize the different type of that means organic product for those which are helpful pharmaceutical, that means pharmaceutical or polymer synthesis, everything from reaction mechanism we can, with the help of reaction mechanism, by knowing the exact part, that means how it is depend on the reactant nucleophile, that means the how it is depend on the substrate, temperature, solvent, everything. Yes sir.
Yes, good.
Sir.
In types of reaction mechanism, explain one by one.
Yes sir. Types of reaction mechanism, sir, that means there are, that means 6 type of reaction mechanism. One is substitution reaction, one is elimination reaction, one is addition reaction, and one is that is pericyclic reaction. One is there, that pericyclic reaction, and one is complex reaction is that one also. And yes, 5 I think, 5 or 6, 5, yes. Complex reaction is also there. Pericyclic I added. Yesterday I did not tell that pericyclic. Pericyclic is also come in the reaction mechanism. Yes, sir. In substitution reaction, that means molecule is substituted by the reactant or substrate has one living group, and the living group is substituted by another nucleophile. Then it is called substitution reaction. And if in pi bond 2 atom is added, then it is 2 atom. If in pi bond 2 atom is added, then it is called basically addition reaction. And if in a from molecule by adding some kind of base or strong base, if the halogen sorry, if some living group or one molecule, some stable molecule is eliminated from the reactant, then it is called elimination reaction. Pericyclic reaction is basically the concerted mechanism, concerted reaction, that means which occur with the help of, without any solvent effect. Yes, that is called pericyclic reaction, concerted mechanism. Okay sir, is it okay sir? सर नेटवर्क फंस गया था क्या? नहीं ना?
नहीं, सही है।
Okay,
एग्जाम्पल बताइए एडिशन के। जो एग्जाम्पल है, इलेक्ट्रोफिलिक एडिशन, न्यूक्लियोफिलिक एडिशन और फ्री रेडिकल, उनको एक्सप्लेन कीजिए पेज पे, फिर मुझे दिखाइए।
yes sir. Okay. Sir, in electrophilic addition, the pi bond of alkene, suppose I am taking alkene and one electrophile, the pi bond of alkene attack the electrophile. Then 1 minute, I'm showing this one. Then one carbocation will form. Suppose I am taking another electrophile, then it will attack. Okay. Okay. So in electrophilic reaction, is it visible? Is it visible, sir?
Yes.
Sir. This one. In this reaction, the alkene attacked by electrophile. Alkene attack the electrophile. Then one carbocation is formed. After that, one nucleophile attack that carbocation and this form. This reaction is basically called electrophilic addition reaction. Okay. Suppose I am taking another alkyl halide, and this halogen is a leaving group. Okay. Suppose I am taking alkyl halide, and the halogen is a 1 minute. Okay. Suppose I am taking this alkyl halide and the halogen is a leaving group, then this nucleophile attack this. Okay, so R nucleophile will form. This is a substitution reaction. Okay, this is basically called substitution reaction. Okay, okay, and if 1 minute. Okay. Okay, so if this one I can explain this one. 1 minute. Yes, sir. In this reaction, you can see that this has strong base. So this base extracted by base, and the hydrogen will go by electron, all the bonded electron. Then the bonded electron will go, and the leaving group will release. This is basically called elimination reaction. Yes, sir.
Yes. Yes, audible.
Yes, sir. Sir, am I audible now?
Yes,
Now,
yes.
that means, yes, sir. In pericyclic reaction, if I add, that means if I react 1,3-butadiene with ethene molecule in thermal condition, then the HOMO of 1,3-butadiene react with LUMO of ethene molecule. Okay, then this will form cyclohexene molecule with the help of pericyclic. That means this reaction is basically called this Okay. Okay. Yes, sir. This one you can see this from HOMO and this LUMO. I in board I can explain more, but now
No
to
problem.
this
Yes,
will be okay. I think this one. Yes, yes, sir. HOMO of this molecule and this. In yes, sir. Okay, sir. And in suppose action also with the help of molecule methane molecule with chlorine in presence of sunlight. That means chloromethane, dichloromethane, that trichloromethane and tetrachloromethane are all formed by free radical mechanism. I can give the proper that means mechanism also. ओके सर, हेलो सर, सुन
यस
रहे हो ना?
यस यस।
हाँ सर, दिस वन, ओके सर।
इसको आप थोड़ा दोबारा रिमाइंड कराइए, इसको दोबारा प्रैक्टिस कीजिए। इसका एडिशन सब्स्टिट्यूशन रिएक्शन जो इलेक्ट्रोफिलिक न्यूक्लियोफिलिक फ्री रेडिकल एडिशन रिएक्शन, इनके एग्जांपल दोबारा एक्सप्लेन करना वंस अगेन।
ओके सर, 1 minute सर। Okay, sir. So that means in substitution reaction, there are, suppose I am taking alkyl halide. Okay. Suppose I am taking alkyl halide. The alkyl halide, if the alkyl halide, suppose I am taking methyl. Okay. Suppose I am taking methyl chloride. Okay. So methyl chloride, if I give some nucleophile, like example OH minus. Okay. If I give some nucleophile OH minus, then this OH minus will attack the carbon center of methyl chloromethane, and that means methanol is formed. Okay, carbon center of chloromethane and methanol is formed. This occur, that means this product is formed by the substitution reaction. That means the OH minus replace OH minus substitute the halogen group. Okay, OH minus substitute the halogen group in chloromethane minus attack. So that means backside. That means the empty p orbital of the carbon. Okay, empty p orbital of the carbon. That means carbon has one is bonding orbital, one is anti-bonding orbital. Then carbon attack that anti-bonding orbital. That means nucleophile attack the anti-bonding orbital of that means carbon halogen bond. Okay, then the molecule is formed. That means methanol molecule is formed, and this methanol molecule has the inverted structure. Okay, if that means methanol molecule has inverted structure in SN2 structure. Okay, since the rate determining step is the attack of methyl chloride. That means with it depends on the concentration of OH minus also, and depend on the concentration of CH3Cl also. Therefore, this reaction is called substitution nucleophilic SN2. Okay, that means substitution nucleophilic bimolecular reaction. Again, if that means if I draw the reaction coordinate, that means diagram, energy profile diagram, that if, okay, I can show you. Yes, if I draw this, then suppose here CH3Cl plus OH minus is there. First collision for this, the energy measure should be like this. After that, this one. That means here methanol will form with the Cl minus, and this is the transition state. This transition state is basically like this. Okay, chlorine, hydrogen, sorry, hydrogen, and this OH minus. Okay, like this. That means this is the transition state for this molecule. Okay, if I am taking another molecule, suppose tertiary butyl chloride. Okay, in tertiary butyl chloride, the alcoholic group, tertiary butyl chloride, the alcoholic nucleophile cannot attack it directly. Okay, so therefore, due to steric hindrance, nucleophile cannot attack it from front side also and from back side also. For this, the alkyl halide with automatically, that means alkyl halide, this is a 3-degree alkyl halide. This alkyl halide will release the halogen group. This alkyl halide will release the halogen group, and it will form a 3-degree carbocation. Okay, it will form a 3-degree carbocation, and this 3-degree carbocation has that means planar structure. This 3-degree carbocation has planar structure. Now, since this is in a planar form, so this is in a planar form. Now, that means the nucleophile can attack from upside also, nucleophile attack from backside also. So, in this reaction, we can get two products. One is that means the same site where the halogen is there, and in one where the that means from back side. So this reaction is basically in this reaction. That means in this reaction we get two products. That means one product is retention of configuration, and another product is the inversion of configuration. Okay, one product is configuration and another one is the inversion of configuration. And in this, that means this is the formation of carbocation is the slowest step. Okay, formation of carbocation, since formation of carbocation is the slowest step, and this will be the rate determining step for this reaction. And since only one molecule, that means
Yes.
Only in rate only one molecule is acting, that means the halide Yes sir, मतलब
ये नेटवर्क प्रॉब्लम था. यस, कैरी ऑन.
am I audible sir? मतलब खुद ही मतलब डिस्कनेक्ट हो गया था. हाँ सर. I am discussing this one. That means in this the reactant is there, and first is that formation of carbocation. That means that this is the transition state. After that, the formation of carbocation. That means this is the intermediate state, and after that the attack of nucleophile is this one, and this the final product formation is there. So the activation energy of first transition state. That means this is more than the second transition state. Therefore, this is the rate determining step, and this is therefore I think yes sir, only for this substitution. Is it okay sir? Correct explanation I think.
Yes.
In board I can explain more. Sir.
Addition, yes. Substitution, elimination, rearrangement.
Yes sir.
नेक्स्ट वन एक्सप्लेन कीजिए.
हाँ सर, एडिशन. हाँ सर, सब्स्टिट्यूशन वो सर ये बोलिए. ओके, सपोज आई एम taking alkene. Okay, so if I am taking alkene, okay, alkene and one the H positive. Okay, so H positive is electrophile, and the pi electron is alkene that exposed. That means it can act as a nucleophile to H positive, and then the H positive is attached with any carbon due to symmetrical nature of the alkene, and this here carbon that means one carbocation will form. After that, if I add nucleophile, that means OH minus, then this one will form. That means this is the addition reaction, where we add two molecules, two atoms. Okay, suppose I am taking another example. Suppose I am taking alkene and I am taking bromine molecule. Okay, I am taking alkene and I am taking bromine molecule. Okay, bromine is like that only. Br single bond is there. So the alkene group of bromine can attack this, and one bromine will release. Alkene, that means pi electron of alkene attack the bromine molecule, and this one will form. Okay, that bromine has two bond is there, therefore it is positive charge in there. Now another bromine releases a Br minus, na? Then this Br minus can act as, here also it can act it can attack there also. So after that, this will form. Okay. This attack this carbon and this will release. So this one will form. Okay. So this is also an addition reaction. This is called basically electrophilic addition reaction. Suppose I am taking one carbonyl group. Okay, one carbonyl group, and I am giving that means Grignard reagent. Okay, I am giving Grignard reagent. Now, okay, Grignard reagent, I am taking RMGX. Okay. Now, since due to Umpalang synthesis, magnesium is positive charge, the alkyl group is negative charge. So, alkyl group can attack this electrophilic center of carbon, and this will attack like that. After that, okay, and this will form OMgX, and here the alkyl group attached. After that, due to hydrolysis, the OH group form. Okay, this is the this part are electrophilic addition reaction, and this part are nucleophilic addition reaction. Yes, sir. This can act as nucleophilic addition reaction. Okay. For suppose rearrangement reaction. Okay. For rearrangement reaction, suppose I am taking this molecule. 1 minute. Which CH3. Okay. 3,3 dimethyl butyl 2. Okay. If I add acid, then the okay. After that, that means this carbocation is 2 degree in nature. Okay. This carbocation is 2 degree in nature. So it can form 3 degree carbocation by that means the methyl group migrate. Okay. 1,2 migration of methyl group. That means rearrangement of methyl group, and this will form. Okay. This will form tertiary carbocation. After that, we can add any nucleophile or anything. So this is the basically a rearrangement reaction. Yes, sir. This is basically a rearrangement reaction. Yes, sir. Almost हो गया, sir. First.
The next one.
Next one, sir, क्या था? एडिशन भी हो गया, ये भी हो गया, और सर क्या था? फ्री रेडिकल. Okay, sir. So for free radical, suppose I am taking 1 minute. Suppose I am taking methane with chlorine. Okay, methane with chlorine in sunlight. Okay, so this can form L2 or CHCl. Okay, so here first one that means this reaction can possible through only this reaction can proceed through free radical mechanism. I can explain this. That means in first step the chlorine the chlorine molecule with the in presence of sunlight it will form chlorine radical. Okay, 2 chlorine radical. Chlorine molecule in the presence of sunlight, it acts it forms chlorine radical. After that, the methane and chlorine, since it forms free radical, so chlorine free radical is in attack the hydrogen of methane. Okay, and attack the hydrogen of methane to form stable molecule that is HCl, and this methane after that, again, this methyl reactive nature again can attack one chlorine molecule in presence since it is present in maximum amount. So, and it can form one CH3Cl and another chlorine radical will form. So therefore, it's going through like this only. So it forms CH3 chlorine radical attack the hydrogen. So again, it forming methyl chloride, dimethyl chloride. So sorry, dichloromethane. Chloromethane, trichloromethane, chloroform, everything. Yes, sir. This is the main basic criteria of like chlorine free radical, peroxide radical, anything, sir. Yes, sir.
Yes. Rearranging.
Is it okay, sir?
I think
Sir, am I audible, sir?
Yes.
Sir.
Addition, subtraction, elimination.
हाँ सर, rearrangement. हाँ सर, सब्स्टिट्यूशन भी दिखा दिया, एडिशन भी दिखा दिया, रीअरेंजमेंट भी दिखा दिया और फ्री रेडिकल दिखा दिया। सर आपका मतलब वीडियो मतलब स्टॉप हो गया था, इसलिए मतलब
एलिमिनेशन।
हेलो सर,
एलिमिनेशन।
हेलो,
जैसे आपकी वॉइस।
हाँ सर, 1 मिनट। ओके सर। हाँ सर, मतलब यहाँ पे बारिश हुआ है इसलिए मतलब थोड़ा दिक्कत हो रहा है।
एलिमिनेशन।
Again, yes, sir.
यस, आपकी वॉइस नहीं आ रही है।
हाँ सर, अभी अभी सर मतलब क्या हुआ है यहाँ पे मोरीगांव में।
यस, एलिमिनेशन रिएक्शन।
सपोज
E1 CB को एक्सप्लेन कीजिए।
यस सर। हाँ सर, ये आपने दिख रहा है ना अभी मेरा पेज?
यस, आपका वो
हेलो सर,
नेटवर्क इशू आने लगा है।
हाँ
कैरी ऑन, मैं समझ रहा
हाँ
हूँ।
सर, पूरा
बोलिए आप कीजिए, कैरी
हाँ
ऑन।
सर। ओके सर, सो यहाँ पे मतलब क्या हुआ, मतलब देयर आर 3 टाइप्स ऑफ एलिमिनेशन रिएक्शन. One is called E1 and another one is called E2 and then another one is called E1 CB mechanism. So in E1, suppose I am in E1 only one reactant will act as a, that means only one substrate can act as the rate determining step in, suppose I am taking this ethyl chloride. Okay, so if first ethyl chloride eliminate, okay, suppose first ethyl chloride eliminate and it form one stable, suppose I'm taking primary carbocation. Okay, after that this hydrogen will eliminate and it will form ethene molecule, and this is basically called, since this is the rate determining step, so this is basically called E1 mechanism. Okay, E1 mechanism. And suppose I am taking another example where, am I audible, sir? Is it okay to understand?
Yes.
Yes. So suppose I am taking another example with in presence of base. Okay, in presence of base, this base will attack the adjacent hydrogen. That means beta position hydrogen, and this hydrogen, that means base will attack the hydrogen with H positive, and all the electron will fall to this bone, and this will form layer. So this in this, that means base and the alkyl halide concentration both determine that reaction. That means both are in presence of reaction. That means the rate determining step. So therefore it is called E2 mechanism. Okay, that is E2 and that is E1. Suppose in another reaction, 1 minute. Suppose in another reaction, this one, the base, 1 minute, this one. Okay, so the base will attack this acidic hydrogen. Okay, so acidic hydrogen attack and it form carboanion. Okay, carboanion. After this carboanion, this will form like that. So first base form one conjugate base. That means it's acid, and this is the conjugate base of this acid. So therefore, this will form. This reaction is basically called E1 CB. Okay, sir. This reaction is basically called E1CB mechanism. That means for E1CB mechanism, the carbocation should be stabilized by electron withdrawing group. That means for in E1CB, we can prepare the alpha beta unsaturated ketone also. With the help of E1CB, we can prepare the alpha beta unsaturated ketone also. Yes, sir. Awesome. Yes.
Yes, good.
Awesome. Thank you, sir.
उनके डिफरेंस बताइए, एडिशन, सब्स्टिट्यूशन, एलिमिनेशन, रीअरेंजमेंट के, यानी 4-5 पॉइंट डिफरेंस.
Okay. Substitution and addition का मतलब substitution में that means there is that means entropy. 1 minute. Substitution in substitution there is no change in entropy. Okay. First thing in substitution that means two reactant in reactant side, two substance in reactant side, two substance in product side. That means there is no decrease in entropy. Suppose I am taking in substitution, one molecule is replaced by another. That means one eliminate and one replace that position. And in elimination, in addition, that means in addition there is no loss of any substance, any atom or molecule. There is no loss of any atom or molecule. In addition, that is the, and in elimination there is loss of substance. There is loss of substance, and in that means yes, this is the main difference. In substitution, one atom replaced by another. In addition, there is only some atom is added, and in elimination, there is loss of element. There is no addition. In elimination, entropy increase. In substitution, no entropy increase. That means there is no change in entropy. And in addition, there is decrease in entropy. Yes, sir. Am I correct, sir?
Yes.
सब्स्टिट्यूशन में मतलब दोनों होता है. सब्स्टिट्यूशन में एंट्रोपी का कुछ नहीं फर्क पड़ता, लेकिन एलिमिनेशन में एंट्रोपी इंक्रीज होता है, एडिशन में एंट्रोपी डिक्रीज होता है. यस सर. और क्या बोलूं मैं? सब्स्टिट्यूशन, एलिमिनेशन. Yes, for substitution and elimination, these are competitive in nature. If I put a strong base, that means if I put strong nucleophile, then substitution occur. If I put a strong base in nature, then the elimination can happen also. Suppose I am taking tertiary butyl chloride. Okay, suppose I am taking tertiary butyl chloride. If I put OH minus, then the substitution can happen. Okay, and if I put the same molecule with ethoxide ion. Okay, suppose I am taking ethoxide ion, then the elimination can product. That means 2-methyl propene can form also. Yes, that means elimination can dominate there. Elimination can dominate. That means in substitution and elimination, they are competitive in nature. Yes, sir. And in elimination, 1 minute, sir. That means for substitution, solvent play very important role in substitution reaction. That means for polar protic solvent or polar aprotic solvent, there is lots of effect for the solvent also in substitution reaction. Yes, this much I know, I think, sir. और सर और कुछ आप मतलब ऐड कर सकते हैं तो ऑलमोस्ट तो मैं
यस, ठीक है, आपने सही चीजें बताई हुई है. E1 E2 एलिमिनेशन और सब्स्टिट्यूशन में क्या डिफरेंस है, कुछ पॉइंट बताएंगे आप?
हाँ सर. That means in elimination they are both are first I told already. That means both are competitive in nature. Okay, first both are competitive in nature, and in substitution if the nucleophile is मतलब If the nucleophile has more nucleophilicity in it, then substitution can happen. If the nucleophile is, that means, if the nucleophile is more basic in nature, more basic, then elimination can happen also. I have to check that. That means the main criteria that for elimination and substitution. Yes, sir. Auto. Yes.
Structure of substrate, nature of the base, है ना? Nature
Yes.
of solvent,
Yes. Yes.
effect of
Structure of
temperature, effect of temperature, yes, no?
Yes. Yes, sir. ये तो मतलब ये that thing I have to write. Yes. Base. Nature of the base. Only I told about nature of the base only. Temperature dependent also. In high temperature, that means 1 minute. In high temperature, elimination is there. In low temperature, substitution is there. Yes. Structure of substance. Yes. For that means tertiary position. That means bulky group. Then elimination can occur easily. Yes, sir. I have to tell this thing. Yes, sir. I will check this. Yes.
Yes, what the difference between Hoffman and SubodhCheM rule? Explain briefly. Hoffman and SubodhCheM. E1, E2.
Yes, sir. That okay. So, sir, if that means if more substituted alkane is formed, from the product, then it is basically called that means SubodhCheM product. And if the less substituted alkane product is formed as the major product, then it is called basically Hoffman product. Okay. So in SubodhCheM product, suppose I am taking alkyl chloride. Okay. Suppose I am taking, I can give one most important example. Okay. Now suppose I am taking 2-chlorobutane. Okay. Suppose I am taking 2-chlorobutane, and in presence of okay, there should be an elimination process. Okay, suppose I list there. So base can attack this from this also. So there are two possible product is there. Okay, two possible product is there. One is 1-butene, but-1-ene, and another one is but-2-ene. Okay, one is but-1-ene and another one is but-2-ene. Okay. Suppose I am taking another example of that is the same thing, only I have sends the halogen, that means fluorine. Okay, I am taking fluorine. That is again the same two product will form due to the two different carbon here. Okay, so here in this that means that means 1-butene will be the major product from fluorobutane, or here but-2-ene will be the major product from chlorobutane, 2-chlorobutane. This is because this alkene is more substituted, and this alkene can be stabilized by 6 hyperconjugative structure. Okay, this alkene can be stabilized by, that means 2-butene can be stabilized by 6 hyperconjugative structure, and this follow basically E2 mechanism, and this follow basically E1 or E2 mechanism. Okay, and here in that means 2-fluorobutane, the only E2 mechanism is follow. Only E1 mechanism is 1 minute. E1 CP mechanism is follow, and here first carbon